Hey Tim, how you doing?
Hey, good. Good morning.
Good. Good morning to you. Happy President's Day, by the way.
Yeah, yeah. We switched to floating holidays, so it's like, yeah, okay, Monday, it's not on the calendar, so yeah.
Good. Well, thanks for joining us today. I appreciate it. It'd be good, I guess, if we could kick off. If you could start back from the early days of Tim, talk us through where you started in life, where you grew up, school, college, that sort of thing, and eventually how you started your early career in the world of U.S. government and the Air Force before joining SES.
Yeah, sure. No, thanks. Thanks for this opportunity. It's a great opportunity. I appreciate it. I grew up in a small western town in Nebraska called Sidney. Most famous for the home of Cabela's, sporting goods. So anybody who's traveled down I-80 usually stops at the Cabela's store. Originally grew up on a farm. My dad had a long lineage of farmers in his family, and when I was about six, we moved to the big town of Sydney of 6,000 people. But we continued to farm. Dad had a various jobs and eventually ended up owning a Napa store. So I spent most of my days there learning about cars and other things, as well as being a farmer. You took a lot of stuff apart yourself and put it back together.
Yeah.
So that kind of led to some of the interesting things I've done. But um, growing up, I was a fairly good wrestler in high school. Had fairly good grades. Ended up getting recruited by the Air Force Academy. So we didn't have a long history of military people in our family and stuff like that. We had a few enlistments. My dad almost served in World War II, but showed up the day they stopped doing medicals for folks to enter. So it was kind of new, a kind of a new experience and stuff like that. And but also being in wrestling and having good grades, I was being recruited by several other schools. I was looking at an engineering degree. So Nebraska, Colorado School of Mines, University of Colorado, and then ended up getting a ROTC scholarship offer as well. And that's pretty normal for the application process for the Air Force Academy. Then I got the letter to join the Nebraska wrestling team. So that decision was pretty easy.
Nice.
Born in Nebraska, Big Red. Yeah, so I went to the University of Nebraska for 4 years. On the Rossi Scholarship, I think at the end of my first year, I was voted most likely not to come back.
Yeah.
I think yeah, at the end of 4 years when we graduated, voted most likely to put in my 4 years of service and get out.
Yeah.
But here was 21 years later, lots of different assignments, and retired out of the Pentagon and still reside in Virginia. So a lot of great opportunities in the Air Force. I originally was going to be a civil engineer designing building.
Okay.
So I was electrical engineer, but I was power focused, power systems, building designs, etc. Did take some digital communication classes. Um, so you fill out a dream sheet your senior year is what do you want to do and where do you want to go?
Yeah.
The Air Force tries to, match that type stuff. Major showed up and saw that I was going to go civil engineering and went, no, 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 no. That's not for you. You're going to go into space or space career field, not into space necessarily. But
Yeah.
yeah, so Falcon Air Force Base was brand new in Colorado, still not operational. So he had me put that down as my number one choice, and the space operations officer is my career field. And so I did end up getting assigned to Falcon Air Force Base, which is now Schriever
Yeah.
Space Force Base. But first assignment was with GPS. Nobody knew what GPS was at the time. We had six
Yeah.
research and development satellites up, nothing operational. Receivers were, this bigger.
Yeah.
And so it's crazy to see where that's gone in my lifetime. Um, so being in the ground roots of GPS, followed that, got a chance to do a little foreign technology. If assess foreign satellites for their capabilities and understand what they could and couldn't do, and feed that back into the operational stuff. And then did some worm gaming for a while, and then ended up at U.S. Space Command 1.0 because we have
Yeah.
U.S. Space Command back again, and there did a lot of classified work. saw a lot of interesting stuff in what they called the special technical operations area that back then you couldn't even really talk about. Got deployed during the Bosnia campaign to support UCOM and a couple missions there. Actually ended up face to face briefing General Clark, the 4-star SACEUR commander during the war. So rare opportunity there. And then after that assignment, ended up at school, then got assigned to the UK, RAF Feltwell. There was a space surveillance site there. We tracked both LEO and GEO spacecraft passively through their RF signals. Then ended up back at the Pentagon, started off in space policy, ended up in some architectural work across the acquisition career field and so forth. And then ended up retiring from there. So that's kind of the Air Force career in short.
Yeah, absolutely. And if you always, I guess, since you went into military and you said you were working that R&D phase, the satellites, and seeing the size of the transmitters back then, and kind of seeing that evolution of the satellite industry back from then when everything was so big. Now you've got CubeSats, microsats, and stuff. Have you always been in the satellite industry? Has that been your kind of main focus once you transitioned into the space ecosystem?
Yeah, everything was space related. So from wargaming was looking at day in the life without satellites, or or if you had more satellites, how would that help the warfighter? Space policy was all about but talking to some folks the other day and stuff, they were talking about taking images from commercial satellite of other satellites in space. It was like, oh my God, that was forbidden. It makes me nervous sitting up here. Hearing you guys talking about this stuff, rendezvous and proximity operations. So we worked all those policy issues in the early days where it really wasn't well known that things were going on and stuff like that. There was experimental satellites by Air Force Research Lab. Surrey Satellite jumped in the middle of that out of the UK and could get away doing stuff that we couldn't get away with on the US side of things, because we'd be portrayed as the bad guys instead of a college sponsoring R&D efforts and investigating capabilities. So it was always kind of funny to watch the international politics around that as well.
Yeah, absolutely. And okay, cool. And I guess sticking on that point around the whole satellite communications industry and all the different companies, could you just give our listeners an overview of what Mynaric Space do, where you are now? How does Mynaric fit in to the sort of overall space ecosystem, and where do you see the company going or evolving over the next 5 years?
Yeah, so Mynaric's focus is pretty singular, and that is to be able to mass produce laser communications to make it affordable for all. As the need for data communications increases, the bandwidth that we have available for RF just isn't going to support it. We see a lot of conflicts at the ITU between sharing of RF frequencies and so forth like that. So when we get into the optical, free space optical side of things, or laser, but not regulated by the ITU because the size of the beams are so small, they don't interfere with each other. And that's really kind of the purpose for regulating RF, was to give folks their own part of the spectrum so they could use it without interference with other folks. So we're kind of an interference free, but also by that inherently secure. Saying earlier to some folks, when we're up at the 1,000-kilometer, 1,500-kilometer LEO altitude where everybody likes to fly right now, when you do a beam from there down to the Earth, you're about 40-meter wide. So for somebody to intercept that, to listen to it, or jam it, deny it, pretty hard to do. So we get the secure by design. We don't have the IT capability. The challenges that were there until now was making it affordable for like LEO satellites and smaller satellite constellations. Before, it was always kind of like the NASA missions, et cetera, that could afford the very expensive laser communications that were developed at MIT or aerospace, or the one-offs. And we really stay away from just doing one-off capabilities, even though our engineering staff has the technological know-how. We like to focus on, once again, back going to the mass production capability. We're rolling about 10 optical heads a week out of our factory right now. We have plans to double that just to meet the marketplace. But it's just not about the space terminal, right? So we can do space to space, space to ground. It's also about
Yeah.
the rest of the ecosystem of having a ground terminal as well, that can communicate to space. Then we had early on, we actually had an air-to-air product, and we still have that kind of in our portfolio, but we're not focusing on that right now. Once again, it comes up to where's the need of the community at right now, and we're probably a little bit early on the air-to-air capability, 10 gigabit per second from one aircraft to another, or a UAV to ground. There's a growing need there,
Yeah.
but still has to develop that ecosystem and the need and the coordination there.
Okay. And I guess sticking on that point and that particular segment of the industry, what's your sort of current thoughts on the status of the laser satellite communication terminal sort of sector, and how do you see that evolving over the next 5 to 10 years? There's a few different applications that you mentioned there, the ground to air and air to air and aerospace defense applications. Where do you see that whole technology evolving in the next 5 to 10 years, and where do you think most of the need will be?
Yeah, I mean, so we see a lot of folks wanting to do the LEO constellations, right? And being able to go from satellite to satellite really significantly reduces your ground footprint. And we've seen some of the current LEO programs struggle because their ground systems behind, because the satellite has to be in contact with the ground station at all times. So go from the user to the satellite down to a ground station, where you can go from the user to the satellite across several satellites and then down to the ground station, or one of many ground stations, depending on what's free operationally, et cetera. Really expands your network without having to complicate a ground network. And the price is coming down to where the intersatellite links are just about the same cost as putting in a ground station. So, and you don't have a lot of the maintenance activities you do with that. So it's really growing. Now, the other problem is laser communications were still susceptible to weather. So space to space, we don't have that issue. Pretty reliable, 99.999%, type reliability between one satellite to another. But satellite to ground, you're going to have geographic diversity, without a doubt, because at some time or another, your ground station is going to be weathered in. You got to have a ground station where the terrestrial network supports it. I can't go put it out in the middle of the desert where there's no fiber optic, because I am talking speeds of 10 to 100 gigabit per second for these links. So it's a combination of the right balance between the ground terrestrial network supporting the uplink and downlink. There's a lot of sophisticated programming that's come out here that are predicting the weather and be able to tell which optical ground station's open and available. Predictive, not waiting till, oh, wait a minute, my link's down because the clouds just rolled in, but actually know the weather setting up to do that. So that's going to be an interesting perspective as that grows and makes itself into the ecosystem. It's really going to enable a lot of the capabilities there. A lot of the business cases for the LEO networks vary, and it's interesting. They're not all trying to do like a Starlink to user to capability, but actually more on the industrial side of connecting data center to data center.
Yeah.
There was one network that actually showed that they could connect the London Stock Exchange to the New York Stock Exchange quicker than the undersea cable system by milliseconds, and those milliseconds would make a large difference in capabilities. So a lot of unique capability out there. Huge growth in the direct-to-device marketplace. They're not high bandwidth users yet, but as technology evolves, I can see them moving into the need to have laser comms on their satellites as well.
Okay, great, thank you. Very interesting. And I guess now that you've been a part of the space industry yourself for so long, you've kind of been through that that evolution, if you like. You've seen the ups, you've seen the downs. What is it that you've obviously stayed in the space sector as well? So what is it you've loved most about being in the space sector? What is it you like most about being in the industry?
Tomorrow is always different than today.
Yeah.
It's a rapidly technology-driven environment that just, direct to device. When people talked about that 10 years ago, they're saying you guys are nuts. reusable launch vehicles, 20 years ago. You guys are nuts. And that's all happening, right? So it's just, it's interesting to see, the getting returned to the moon and then on to Mars, the efforts going on there. It just excites everybody that's involved in trying to make that happen. So it's a fun industry to be part of. It's much more complicated than one would think.
Yeah.
But solving those complication things and watching the policy changes, I mentioned that earlier, right? I mean, where things were forbidden for U.S. companies to do before. Just even go back to the early days, spot image was taken, 30-meter images, and the U.S. companies couldn't do that. So the Commercial Remote Sensing Act that enabled that, and watching things get turned around to where now it's basically open to do anything within your imagination. Yeah, watching it grow and continue, it's always different.
Awesome. And I guess keeping on that trajectory you mentioned there of growth, one of the main kind of motives, if you like, for us starting this podcast was to try and make space accessible for everyone. And one of the sort of the hot topics across space is the kind of sustainability of that growth from talent for the future. And when I go out to the US and I go to these events in DC and Colorado and LA and everywhere else, one of the concerns that seems to be consistent is that the space ecosystem is growing. That's great. There's lots of new companies coming out of the woodwork. It's not really getting any easier to find the talent to kind of sustain and maintain that growth. So what do you feel we could and should be doing differently across not just the industry, but kind of at a general STEM level? So schools, colleges, university, to try and impact the change now to encourage our sort of future generation to consider space as a potential career. Is there anything we can be doing differently in the classrooms and spreading the message? I guess not just in the classrooms either, at the grassroots level. That's obviously important, but even I still speak to friends and family now, and as soon as I say space, they think rocket science, astrophysicists, astronauts, and that's it. So is there anything you think we can be doing differently there?
Well, there is a lot of STEM efforts, and I'm part of a couple of organizations that really focus on that, getting into the schools, colleges, et cetera, offering scholarships for folks to pursue one of the STEM type environment classes and stuff like that, rather than be engineering, math, science, general technology. But I think it's also parts of the industry that people really don't think about, and it's one of the things that we've lost in schools, is really what got me interested in engineering and building stuff was a woodworking and electrical class I took in college or high school, where we were building walls and wiring stuff up and learning how to wire things. And those occasional classes kind of almost disappeared from our high schools, and yet that's what got me excited about electrical engineering, was learning more about how the electricity flowed through the switch and all the other things that went on. Vocational, because look, we need welders, right? I mean, we need the hardcore technical build, or the physical guys that are out there doing stuff. Lawyers, there's a lot of room for lawyers in space with the regulatory environment we have and stuff like that. And just even people right out of high school, there's opportunities in space for that. So we have to emphasize that as well. Like you said, not so much focus on the rocket science, and you have to have engineering or PhDs to work in space. There's plenty of room for everybody, and it's exciting all the way up and down the chain.
Yeah, absolutely. And I think the message there is kind of all those different areas you mentioned, the electrical, the mechanical workshops, the law, whatever, sales, whatever it is I guess to those people that are kind of from the outside looking in, thinking that it is beyond their reach and it is all astrophysicists, is making it relatable. So what they're doing, they can do the same thing in space. Like you just mentioned there, law, electrical wiring, mechanical, everything else.
Yeah, I mean, it covers all gamut. Like I said, we focus a lot of times just on the STEM side of things, but I think it goes beyond that and reaching further out, encouraging people to look at space careers. And now it's just not located to a couple of regions, right? I mean, I look at where the space startups are going, and Austin, Texas, Denver, Colorado, Arizona, Utah, New Mexico, Florida, Virginia.
Yeah.
It covers, and that's just looking at the U.S. obviously, right? And when I look over in Europe and stuff like that, there's a lot of pockets in Europe, from Belgium to Munich,
Yeah.
Germany. Yeah, you always think of Toulouse, France, and then with Airbus there, and then obviously Thales in France as well. But actually, a lot of the work for Airbus Space isn't in Toulouse; it's in Germany, so and the UK.
Yeah, yeah, absolutely. And just, I guess, sticking on the kind of theme of the younger generation, along with that comes things like social media platforms. The next thing I want to talk to you about is failures and achievements. I think with all the, various social media platforms out there now, LinkedIn, Twitter, everything else, I think you only see the end goal, the end result. Everyone kind of posts the highlight reel, if you like, of
Yeah.
their wins. So I guess in terms of thinking about the work that goes on behind those scenes, the grind, the sacrifice, the commitment, all that kind of stuff, could you just talk us through what would you consider your biggest failure or lesson that you've learned career to date, and what did you learn from that lesson? On the flip side of that coin, it'd be good to know what you feel is your biggest achievement to date.
Yeah, I mean, I wouldn't say there was any really big failures. There were some obviously things that didn't work out the way you
Yeah,
wanted them to, and or challenges. Once I got into the business development side, I mean, every loss is a gut shot that you're like, what did we do wrong? Why didn't we win that? Especially where you kind of you put a lot of time and effort, and sometimes 24-hour days into a proposal, to have it evaluated and find out that you missed something, or stuff, stuff that you should have known that you didn't get in there or properly communicate. So those are tough losses for not only myself, but the entire team, right? And it really is a big gut shot when you get that notice that said, sorry, you weren't selected.
yeah,
And it doesn't matter if you're applying for an astronaut job or putting in a proposal. So anytime you really look forward to achieving something, and then unfortunately you fall short for whatever reasons, those are all things that make you stronger, and you take the lessons learned and say, okay, what do we do differently next time? And one
yeah,
of them, you know, you find ways to improve in that area that was kind of identified as a weakness for you. Um, Kind of skipped over something I want to go back to. It's like when I was my last couple of years in the Pentagon, um, we received a note from then Secretary Rumfield asking us if we were too reliable on space.
yeah,
And so that kicked off this assessment that I got tasked to lead of spacecraft vulnerability, and how reliant was the military on this. And at that point, commercial space wasn't really talked about. But then it was discovered, wait a minute, 80% of our communications in and out of theaters goes across commercial SATCOM. And we really don't know how well those guys are protected. What are they doing to protect themselves? And so I kicked off a second study of talking to all the commercial operators to find out, hey, do you badge people into your facility, or can somebody just walk in here and take down a whole teleport, right? And take critical military communications off the air. So that's how I learned about SCS and Intelsat and the other companies. So when I retired, I started at SCS, doing hosted payloads. Uh, and that's why I kind of wanted to go back to that, because that's probably one of the bigger successes that I had, even though it took a team. I just happened to be the one
yeah,
that got assigned to lead the team. And we did a commercially hosted payload on an SCS satellite that was an experiment for infrared sensing. And really, the phenomenology we found and tracked there, not just missiles and stuff like that, but other capability, was just amazing. Led to the fact that we could detect fires earlier than most people knew they were even
yeah,
starting in the mountains in California, and so forth like that. So that's led to some of the efforts to revise it still today, called FireSat, and be able to do that warning. Uh, that program definitely was one of the highlights of my career, and we still talked about today about how
yeah,
successful it was. That was 20 years ago. So for some to still have that legacy was pretty cool.
yeah. That's amazing. awesome achievement. And I think with the going back to what we were talking about around the spreading the message and the various STEM initiatives that you're included in as well, for anybody sort of listening to this that still feels that space is all astronauts and astrophysicists and all that kind of stuff and it's beyond their reach, would you say there was any particular resources that you identified and sort of utilized over the years, whether it be courses or programs or mentors maybe that you had along the way that kind of helped you transition to the space sector? Early on, you mentioned about being in the military and someone saying to you at the time, actually, no, you need to be in the space sector. But is there any sort of resource they can tap into to kind of, I guess, make that first step?
Yeah, I think one of the hidden gems is, if you're in an area where you can go to some of these major symposiums, conferences, and you get an exhibit pass and just walk around and talk to people. The exhibit pass are normally free. I don't think most people know that. They're held around the world to be able to get in on the exhibit floor because everybody loves to talk about their product, right? And from that, you can learn about all the different things that are going on in space. And that's where you talk to the machinists, you can talk to, the highly sophisticated new design of propulsion systems, et cetera. I learned a lot from walking around those floors and just talking to people. Of course, they're usually trying to sell you something, so you kind of have to put on I'm not interested in buying, but I'm interested in learning about your technology. And we do a lot of that ourselves. We do a lot of educating of folks. When I was at SCS was not a common name in the military. I would say that now, if you're in the satellite business and in the military, you know of SCS and Intelsat, and like I said, it wasn't commercially known, or wasn't known that the commercial guys were that important to the military operations. So we're not. Same thing when I was at Airbus US. Everybody thought of Airbus as being European, going out and explaining that, hey, this is what we do in the US now. And now at Mynaric, we spend more time talking about just the capabilities of the laser comm and how that works. And then, of course, what we do in that ecosystem, like you pointed out earlier. I think that's one of the easiest jumps for people that are out there looking for their career, if they're in an area where the symposiums are held, or go to one. I mean, but then, like I said, you usually not have to go too far if you look. But the other thing is mentors are the best way to learn stuff.
Yeah.
And we talked to some folks the other day about, yeah, bug somebody like me, send me notes and say, hey, let's get together for a cup of coffee. Most people will take the time to talk to somebody that's interested in learning more about the space capabilities, etc.
Yeah, absolutely. And I think going back to what you're saying about the conference as well, I totally agree. And it's from my experience, Sam, I mean, I've only been doing this for 7 years, but everyone's so friendly and approachable as well at those conferences. Like, I typically try to go to the satellite in DC every year, the symposium in Colorado, and the small sat over in Utah, which will be in Salt Lake this year. But everyone's so easy to talk to as well. They're willing to kind of give you that info and guidance from my experience anyway.
Yeah. Like I said, everybody's like in a more relaxed, approachable, environment, stuff like that. So it works out well.
Yeah, absolutely. And I guess the final question for me is kind of pegs into the last question, is that what is the number one sort of advice you would give, again, for someone who's kind of listening to this, and whether they're technical or non-technical, don't have to be an engineer doing wiring, they could be in, like you say, law and sales, HR, whatever it is. If someone is looking into the space sector now and thinking, I really want to get into the space sector this year and beyond, what's the main advice you'd give to those guys listening to this podcast now?
There's a lot of opportunity. I mean, everywhere you look. Unfortunately, the headlines that have hit lately are right, the layoffs that have happened in the industry and stuff like that. But there's just many small companies out there ready to pick up people, especially in the engineering. We're always looking for engineers. I think every company is out there. But even across the various disciplines out there, like you said, finance, supply chain, are all critical to our success of companies. And a lot of people don't think about that when they think about the space. So, but it continues to grow. Everything I look at,
Yeah.
from all the analysts and stuff like that, still predict the space, become $1 billion, $1 trillion economy as we go forward into the 2030s, 2040s. So the opportunities are just going to continue to grow, and what a great place to be is in a sector that's going to continue to grow versus some of the other ones that are going to retract.
Yeah, absolutely. Couldn't agree more. Awesome. Tim, thanks ever so much for joining us today. I really appreciate it. Thanks for your time.
No, I appreciate the opportunity.